Hi, my name is Sakari Tolppanen. Welcome to learn about sustainable energy. Today our guest is Dr. Hannele Holttinen, who is the principal scientist at VTT Technical Research Center of Finland. She has worked for VTT for over 20 years in different fields of wind energy research and has published multiple significant research articles on the topic. She is also active in international collaboration, for instance in the International Energy Agency and EU technology platform TP Wind. It is a great privilege to have Dr. Hannele Holttinen here with us today to share knowledge on wind energy. Hannele, it's a great pleasure to have you here with us at the studio. I'm sure our guests have a lot of questions they would want to ask you, but unfortunately they're not able to be here with us today, so I'm just going to ask a few general questions from you. So, when we're talking about wind energy, can you first tell us how do we actually make electricity out of wind?
Yes, so wind energy is kinetic, it's moving. So that's why we build turbines, wind turbines, as you see here. So basically the main elements are the blades. So these blades capture the moving wind and start rotating. And from rotational energy, it's easier to make electricity because generators create electricity out of rotations. And this is why here, in this small place here called nacelle, we have a generator that is then connected to the electricity network. And because generators spin very fast, there will be a gearbox normally in between. Or then there are also new solutions where the generators can be spinning more slowly. So basically we have as components, we have the blades, and then we have the nacelle that contains the main mechanical components. And then of course this structure needs to move so that when wind blows from different directions, the whole nacelle moves. So there is a yawing motor moving the nacelle so that it will always capture the wind from the right direction. And then there will be a tower, and this is also pretty important because we want to get the structure as high as possible because the winds are much stronger in higher altitudes, like 100 meters above the ground level. And also, since these are quite large structures nowadays, it's important that when you place several wind turbines in a wind power plant or a wind farm, then they cannot be exactly one after the another, but you have to have some space in between so that the winds passing through one rotor will have time to recover and have energy for the second one. And this of course depends on the site and where the prevailing winds come from, how far you can or how close you can place these turbines. But it's obvious that wind turbines will require space around them to catch a free wind with a lot of energy. But then again, it's also possible usually to use the space in between the turbines.
Thank you very much for the elaborate answer. My follow-up question is, when we talk about wind electricity, we typically talk about green energy. And after all, the whole turbine is made out of steel and infrastructure is needed for wind farms. So how green is actually wind energy?
So when wind turbines operate, they do not produce any emissions. So it's emission-free electricity. But of course, in order to be strictly to look at what is the whole impact, there are life cycle studies done to see how much energy is used to make the turbines. For example, steel and copper and glass fiber for the blades, for example, and concrete for the foundations. So all these materials are calculated how much they consume energy to make them. But then, of course, after the wind turbines end of life, many of the materials can be circulated. For example, steel and copper are always circulated back. So when taking this into account, they have estimated, there are several estimations, but it's from a couple of months to perhaps half a year is the time after which wind turbine will gain back the energy that has been used while making the turbine, and then it will start creating emission-free electricity.
Okay, thank you. So that's very positive news. What about the turbine itself? How long does it typically last?
They are usually planned to last for 20 years, and we have now seen from turbines that have been built in the 80s and 90s that some of them are actually kept for 20 years or even more, and some of them are kept perhaps 15 years. So that's basically normally how long they last. There are some components that may have to be replaced in some turbines. For example, gearbox or generator may have to be replaced, and in some turbines blades may have to be replaced, but not in all of them.
So this replacement is done within this 15 or 20 years?
That's right. In some cases, some of the components will be changed during this time.
Great. And I guess one of the challenges with wind power is that sometimes you go by or drive by a wind turbine and you realize it's not moving, and obviously that's because it doesn't always wind. The wind doesn't always blow. So what is a strong enough wind to actually move a turbine of that size, and where should the wind turbines be placed so that it's economically feasible to actually build wind turbines?
Depending on the turbine type, they normally start producing at about 3 meters per second wind. And then I mean the wind normally that comes to the hub so on top of the tower, what is the wind speed there? So sort of 3 to 5 meters per second wind, that's when they start producing. And then they will produce according to the wind speed. So when it blows more, they produce more, and when it blows less, they produce less. So it will vary all the time because the winds do vary all the time. And then when it's really a lot of storm, then they will stop to protect the structures. But that's normally after 20 meters per second or even 25 meters per second. So that's really a high storm that, for example, here in Finland, we don't have that kind of storms every year.
So the role of renewable energy is growing fast. So how do you see that wind energy fits into the big picture?
So far there has been a big drive to build wind energy, because in many countries it's the only renewable energy that can still be built. It's not all countries have hydropower available, or hydropower that can still be built more than what is now already built. And not all countries have biomass to use. So wind energy seems to be available in most countries, and that's why it has been built a lot when countries try to strive for renewable electricity system. There are, of course, other alternatives, and it's good that there are other alternatives because the wind doesn't always blow. So wind is a part of a portfolio, of a renewable portfolio. In some countries it will be more built, and in some countries a bit less, but so far the future looks like it is really needed globally in almost all places.
Thank you for answering these questions. I'm looking forward to hear your lecture on this topic.
Thank you.